In this video, we're going to assign oxidation numbers to atoms that are inside a covalent compound. Now, in a covalent compound, rules 1 and rules 2 are not going to apply. Rule 2 only works when you have ions present. If you've got no ions, you're going to have to start really with rule 3. Let's try one. Suppose I give you carbon dioxide and I ask, what are the oxidation numbers on the carbon and the oxygen? All right, start with the rules in order. Do you have just one element? No, I've got two elements, carbon and oxygen, so that rule does not apply. Rule 2, do you have any elemental ions? No, you don't have any ions at all because this is not an ionic compound. It's a covalent compound. How do I know that? Both of these elements that I have in my formula are nonmetals. If it were ionic, I'd need a metal and a nonmetal, but I don't have that. So rule 2 does not apply. So now I'm going to go down to rule 3. The sum of the oxidation numbers has to be equal to the total charge. Okay, the total charge of this is 0. So that means that the oxidation number on the carbon plus 2 times the oxidation number on the oxygen has to be 0. Okay, that's where rule 3 takes me. I got to go a little further though because I have one equation with 2 unknowns. Let's go down to the next rule and see if that helps. It says, do you have any fluorine? No, we don't. Do you have any hydrogen? No, we don't. Do you have any oxygen? Yes, we do. It says if you've got an oxygen at this point, you can put a -2 on it, even though it's a covalent compound. So this thing here is a -2. That makes my equation into the oxidation number on the carbon plus 2 times -2 equals 0. Okay, that's the same thing as the oxidation number on the carbon -4 equals 0. And then if I add 4 to both sides, I get the oxidation number on the carbon is equal to 4. I can say plus 4. So I found that the oxidation number on the oxygen is a -2. The oxidation number on the carbon is a +4. So this will be what happens anytime you find a formula with a lot of, with only nonmetals in it. You're really going to be starting at rule 3 with this type of compound. Let's do another one. How about hydrogen peroxide, which is a bleaching agent? There's the formula. Now, take a look at this formula. In worksheet 4.1, we learned how to classify things as covalent or ionic. Which one is this? Look at the elements on your periodic table. They're both nonmetals. So it's going to be a covalent compound. Rule 1 does not apply because we have 2 different elements. Rule 2 does not apply because we don't have any ions at all. It's a covalent compound. Rule 3 does apply. It always applies. 2 times the oxidation number on the H plus 2 times the oxidation number on the O has to add up to 0 because 0 is the total charge on the formula that I have right here. All right, I have one equation, 2 unknowns, so I have to keep going. The next rule says, do you have any fluorines? Nope. The next rule is, do you have any hydrogens? Yes. And I can put a +1 on them if I hit rule 5. So I can put a +1 here. So my equation has become R8. I know the oxidation number on the hydrogen is +1. Let's solve this equation for the oxidation number on out. If I subtract 2 from both sides, I get this. Got to be careful with signs here. When I subtract 2 from both sides, there's going to be a minus sign there. And now if I divide both sides by 2, I get the oxidation number on the oxygen to be -1. So that's an unusual oxidation number for oxygen. Notice that I stopped at rule 5. I didn't go down to rule 6 to assign it on the oxygen. What would have happened if I had done that? I'd have it wrong. I would have put 2 +1s on the hydrogens and 2 -2s on the oxygen. Here's how I can check to see that this is right. Rule 3 says that all the oxidation numbers have to add up to the total charge, which is what I wrote down there. So try it out with the oxidation numbers you got. 2 times +1 plus 2 times -1 does equal 0. That works. But what if you had put the -2 on the oxygen if you had gone further than you needed to? Rule 5 was where we stopped. If I had gone to rule 6, I would have put a +1 on the hydrogen and put a -2 on the oxygen. And I could check that way. I violated rule 3. So you can, you've got to watch out that you do the rules in order and that you stop as soon as you know enough to assign oxidation numbers on all of the atoms in the compound. Don't go any further. So it would have been wrong for me to put the -2 on the oxygen. So this is kind of a tricky example here. Let's do another one. This is potassium superoxide. Now, this will be an ionic compound. I've got potassium in there. And that's a metal. So I have a metal and a nonmetal, so it'll be an ionic compound. But it's not going to work quite the way I would expect it to. If I do the rules in order, I'm going to be okay, though, and I'm going to get the right answer. Let's do them all in order. Do I have just one element? No. I've got 2, potassium and oxygen. So rule 1 does not apply. Rule 2, do I have elemental ions? Yes. I have one that I recognize right away. Potassium is in the alkali metal column, the first column on the periodic table. Everything in that column forms +1 ions. So that's really a potassium ion that's in there. And I can use rule 2 to say the oxidation number is the same as the charge for that. So it is an oxidation number of +1. Now, if I look at the rest of it, what does the charge on the rest of it have to be to make the whole thing electrically neutral? Well, if this was a +1, the rest of it altogether has to have a -1 charge. So I've got this thing here. Now that is not 2 oxide ions stuck together. That is not 2 O-2s. Let's go on and see what we get. Okay, if I apply rule 3 to just this piece, the sum of the oxidation numbers has to be the total charge. 2 times the oxidation number on the oxygen has to be equal to -1, because that's the total charge. And I don't have to go down any further. If I divide both sides of this by 2, that's the oxidation number. So I don't ever use this rule down here. I can stop at rule 3 with this one, and it is possible to have a fractional oxidation number. This thing has got some very interesting chemical properties because it has such an unusual oxidation number on the oxygen. One of the things that this can do is it can react with carbon dioxide and regenerate oxygen. So people use it in scuba gear in rebreathers. And it works because of this unusual oxidation number that the oxygen has got. All right, let's try another hard one like that. Let's do F2O. To get the answer for this one, you've got to apply the rules in order. All right, do I have one element? Nope, I've got two, fluorine and oxygen, so that doesn't apply. Do I have any elemental ions in here? No, because this is a covalent compound. It is not ionic. I know that because these are both nonmetals. So that rule doesn't apply. Rule 3 does apply. 2 times the oxidation number on the fluorine plus the oxidation number on the oxygen have to add up to 0 because that's the total charge on that thing. Okay, I got to go further because I have 2 unknowns here. I go down to the next rule. It says, got any fluorine? Yes, I do. So I can put a -1 on that. Okay, that's enough to give me the oxidation number on the oxygen. I don't need to go any further. All I need to do is solve this equation for the oxidation number on oxygen. So this is -2. If I add 2 to both sides, I'm going to have the oxidation number on the oxygen is equal to, if I add 2 to both sides, 2. I can write +2. Now that's an unusual oxidation number for oxygen as well. It's a +2. Usually oxygen's got a -2, but not in this compound. So you can see that in covalent compounds especially, the oxidation number that you end up putting on the oxygen is not always what you would expect. You would expect a -2, but if you apply the rules in order, you will see cases where you don't have that. If you can do these last couple, if you followed that, and if you can do examples like that, I would say that you've mastered this. There are a lot more examples of this on the homework. Do them. And there are more examples in the book as well. And if you want to see some more examples, ask me in class on Monday after break.